Here is a quick math refresher. Integers. These are whole numbers which consist the positive and the negative whole numbers, including 0. Examples: -2, -1, 0, 1, 2, and so on. These are what we call the integers. Divisibility and factors. If an integer m is divided by an integer n and there is no remainder in the quotient, then we say that m is divisible by n. We can also say that n is a factor of m. For example, 12 is divisible by 3, but 12 is not divisible by 7. So, 3 is a factor of 12, but 7 is not. Other factors of 12 are 1, 2, 4, 6, and 12. And 12 is a multiple of 1, 2, 4, and 6. Even numbers and odd numbers. Even numbers are integers exactly divisible by 2, while odd numbers are those not divisible by 2. Some of the even numbers are 2, 4, 6, and 8. Some of the odd numbers are 1, 3, 5, and 7. To determine whether a sum, difference, or product is even or odd, you may pick numbers, plug in, and check the result. You may refer to the following rules. Prime numbers and composite numbers. Prime numbers are integers divisible only by itself and 1. Example: 2, 3, 5, 7, 11, 13, and 17. Composite numbers are integers with factors other than 1 and itself. It can be represented as product of 2 or more integers. For example, 4. Factors of 6 is 1 times 6 and 2 times 3. 6 is a composite number. Prime factorization. It is a process of expressing a number as a product of prime numbers. For example, the prime factorization of 30 is 2 times 3 times 5. For 70, that's 2 times 5 times 7. Multiple. If k is a factor of m, then there is another integer n, such that m equals k times n. In this case, m is called the multiple of k. Since 10 equals 2 times 5, 10 is a multiple of 2, and also 10 is a multiple of 5. Any integer is a multiple of each of its factors. Least common multiple. It is the smallest non-zero integers that is divisible by each of a group of numbers. To find the LCM, check out the multiples of the larger integer until you find one that's also a multiple of the smaller. That is why I always remind that it's very important that you memorize the multiplication table. For example, the LCM of 4 and 6 is 12 because 12 is the smallest number that is divisible by both 4 and 6. Squaring a number and cubing a number. To square a number means to multiply the number by itself 2 times. Thus, 5 squared is 5 times 5 or 25. Similarly, the cube of a number means multiply the number by itself 3 times. That's 2 cubed. That's 2 times 2 times 2. That's 8. Square roots. Finding the square root is the reverse operation of squaring a number. If 5 squared is 25, we call 5 a square root of 25. Cube roots. Finding the cube root of a number is the reverse operation of cubing a number. If 5 cubed is 125, we call 5 a cube root of 125. If 2 cubed is 8, we call 2 as the cube root of 8. Fractions. A fraction is a number which represents a ratio or division of two integers, written in the form a over b, where a is called the numerator and b is called the denominator. If a is less than b, the fraction is called proper fraction. If a is less than or equal to b, the fraction is called improper fraction. Mixed number is consist of integer followed by a proper fraction. 3/4 is a proper fraction, 4/3 is an improper fraction, and 1 1/3 is a mixed number. Comparing fractions. It is easier to compare fractions if we convert them to decimals, such as 3/4 is 0.75 in decimal, 3/5 is 0.60. So since 0.75 is greater than 0.60, then 3/4 is greater than 3/5. Equality of fractions. If two or more fractions yield the same quotient when the indicated division is carried out, the fractions are equal. Reducing fractions or simplifying fractions. To reduce a fraction to lowest term, factor out and cancel all factors the numerator and denominator have in common. For example, 6/8, they have the same factors of 2 from the numerator and the denominator, so cancel it out. The lowest term is 3/4. Multiplying fractions. To multiply fractions, multiply the numerators and multiply the denominators. Cancel where possible to reduce the amount of multiplication. Multiplying mixed numbers. Convert the mixed numbers to improper fractions before applying the rule as you would with proper and improper fractions. For example, 1 1/2 times 2 3/4, that's 3/2 times 11/4. 3 times 11, that's 33. 2 times 4, that's 8. Or that's 4 1/8. To divide fractions again, that's keep, change, and flip. Keep the first fraction, then change the sign from division to multiplication, then invert the second one, then perform multiplication. For example, 3/2 divided by 11/4. So keep 3/2, change the sign, that's multiply, then flip the second one, that's 4/11, then multiply. 3 times 4, that's 12. 2 times 11, that's 22, or that's 6/11. Multiplicative inverse. To find the multiplicative inverse or reciprocal of a fraction, switch the numerator and the denominator. For a mixed number, convert first to improper fraction before switching. For a decimal, you may convert the decimal first to fraction or simply divide 1 by the decimal. Additive inverse. The additive inverse or opposite of a number in the same number with the sign change, such as the opposite of 6 is -6, the opposite of -9 is 9. The sum of two opposite numbers is always equal to 0. Fractions, decimals, percents. To convert fractions to decimals, simply divide the numerator by the denominator. From decimals to fractions, write out the numerator and denominator in full and reduce to lowest term if necessary. From decimals to percents, move the decimal point 2 places to the right and affix the percentage sign. From percents to decimals, drop the percentage sign and move the decimal point 2 places to the left. From percents to fractions, drop the percentage sign and write the fraction with the original number as a numerator and 100 as the denominator. fractions to percents, change fraction to decimal, and then move the decimal point 2 places to the right and affix the percentage sign. Percents. The basic percentage formula is A equals base times rate, where the base is the whole of original amount on which a percent is calculated, and the rate is a figure that shows the relationship between the base and the amount. The part of a base found by calculating a percent is called the amount. In here, 50% of 60 is 30. Here, 30 is the amount and 60 is the base. So 80 is what percent of 50? Note that phrase of 50 means that 50 is the base and 80 is the amount. To solve for the percent of a number, multiply the base by the rate. You may need to change the rate, usually expressed in percent, to decimal or fraction. In solving for the rate, divide the amount by the base and change the result to percent. In solving for the base, divide the amount by the rate. Ratio. The ratio of one number, A, to second number B is the quotient A over B. The ratio of A to B sometimes is written A is to B. Ratio is a fraction, and any fraction can be described as ratio. Proportion. It is a statement that two ratios are equal. In the proportion, A is to B is equal to C is to D. The outside terms A and D is called the extremes, and the inside terms B and C are called the means. In a proportion, the product of the means is equal to the product of the extremes. Thus, for a proportion A is to B is equal to C is to D, AD is equal to BC. The rule is more common to us as cross multiplication. For example, 5 is to 8 is equal to 10 is to 16. So the means are 8 and 10, which is 80, and the extremes are 5 and 16, which is also 80. Average. Average is equal to sum of the terms divided by the total number of the terms. For example, find the average of the 5 numbers 2, 3, 4, 5, and 6. First step, add the numbers. That's 20. Second step, divide the sum by 5. That's 20 divided by 5, that's 4. Thus, the average is 4. Evaluating an expression. To evaluate an expression, plug in the given values for the unknown variables and calculate according to PEMDAS. Evaluate first the parentheses and exponents, followed by the multiplication and division from left to right, and addition and subtraction from left to right. Translating phrases to algebraic expressions. To translate the phrases to algebraic expressions, look for the key words. Be careful about the order, especially when subtraction is called for. It is important to have a working knowledge of common words that translate into symbols for addition, subtraction, multiplication, and division. Some of the common words that denote addition, subtraction, multiplication, division are listed below. I'm also leaving you here the conversion of units.